Welcome to this finance video on timelines, part 1, brought to you by the Answer series. This video will look at the effectiveness of timelines in summarizing a lot of information. Let's have a look now at how to create a timeline. First, we place the time periods on a line starting with T0 to represent the start of a time period. A time period could be, for example, years or months or weeks, and for this we take our lead on which time period to use from the information given in the question. T1 would then indicate the end of the first time period, T2 the end of the second time period, and so on up until Tn, which will indicate the end of the time periods. The best way to illustrate the effectiveness of using timelines is by looking at examples. So let's take a look at our first example here. We have a man who deposits 2,000 Rand into a bank account. The interest rate is 7.5% compound interest per annum. 2 years later, he deposits another 3,000 Rand, and after another 3 years, he deposits 5,000 Rand. We have been asked to calculate how much is in his account 10 years after his first deposit. Now that is quite a lot of information in those 3 lines, but it can easily be summarized on a timeline. First, the thing is to note that we are working in years. So we show that at the initial phase, at T0, 2,000 Rand is deposited. 2 years later, at T2, 3,000 Rand is deposited. And 3 years later, at T5, 5,000 Rand is deposited. We also include the interest rate on the timeline for reference. When posed with a question like this, one might be inclined to follow the path of each amount until the next amount is reached. So, for example, in this case, calculating the compounding growth of the 2,000 Rand over these first 2 years, then adding the 3,000 Rand and compounding this new total over the next 3 years, and finally adding the 5,000 Rand and compounding this new total for the remaining 5 years. This approach is not incorrect, but we would like to develop methods that will enable us to work succinctly and efficiently in the future. Let's rather consider the full journey of each amount separately using the compound increase formula for each deposit. So instead of calculating each step separately, by considering the journey of each amount, it is possible to do the calculation of the total final investment in one step. So let's have a look at each amount's journey. The 2,000 Rand compounded forward 10 times. The 3,000 Rand compounded forward 8 times. And the 5,000 Rand compounded forward 5 times. Together, they give the amount in the man's account after 10 years. Another thing about doing separate calculations is that it can lead to the temptation to round off mid-calculation. And we need to avoid this temptation. So doing the calculation all in one step is likely to be the most accurate. Then just a note on the memory on your calculator. This is a powerful tool when it comes to finance. It can save you time and can help you avoid inaccuracies. Take an example like this one above. Instead of repeating the writing and typing of 1 plus 0.075, you can save it into memory. Using memory A means that when you then type this out on your calculator, you just recall the A each time instead of typing that out each time as above. This next example is the same as the previous example except for one difference. This time, the man needed to withdraw the 3,000 Rand from his account after 2 years. Let's look at how we show that on the timeline. It can be indicated with a minus sign or alternatively with brackets. We are going to use brackets to indicate a withdrawal in this video series. The important thing is, whichever method you use, the distinction between a deposit and a withdrawal must be clear. Note the withdrawal needs to be subtracted. And now we can see that this time the amount in the man's account at the end of the 10 years is this. Now let's have a look at what we do when there is a change in interest rate during a time period. This time, the story is that 5,000 Rand was deposited into a bank account, and then it is given that first of all the interest rate was 7.25% per annum compounded annually, and then after 3 years it changes to 7.5% per annum compounded annually. We've been asked to calculate the amount in the account at the end of 7 years. First of all, let's show here that we are working in years. Then, to show the change in interest rate on our timeline, we draw a long vertical line to indicate the change clearly, in this case after 3 years. This line shows nice and clearly that the 7.25% was for the first 3 years and the 7.5% for the remaining 4 years. So when it comes to doing the calculation, we need to calculate what the amount will be after 7 years, in other words, the amount at T7. This will be the deposit of 5,000 Rand compounded over these first 3 years by the first compounding factor, and then changing to the other compounding factor for the remaining 4 years. Remember to practice this calculation on your calculator. And just a note in this case, using the memory will not add to efficiency or accuracy because the interest rate isn't repeated over and over like before. You will also come across questions where you are asked to calculate P in a compounding scenario. Instead of substituting the given values into the standard compound increase formula and rearranging it, we can actually derive a formula for P, which is then much slicker to use. From the compound increase formula, to make P the subject, we need to divide through by the bracket to the power n. We can then rewrite this using exponential laws as a brackets 1 plus I to the negative n. Then we can use the formula in this format when we are needing to calculate the present value of an item we have been given the future value of. Let's have a look now at an example. So here, a business took out a loan. The rate of interest was 18% per annum, and the loan is to be repaid in 2 installments, 45,000 after 3 years, and a final amount of 50,000 after 10 years. We have been asked to calculate the value of the loan. Lots of information given in this question of things happening at different times, so a great opportunity to use a timeline. Maybe pause here and give it a try first before moving on to see the solution. So first of all, let's remember from the question that our time periods are in years. Then here you can see the 45,000 at T3 and the 50,000 at T10. And then just a reminder to always add in the interest rate on the timeline. We have been asked to calculate the value of the loan, which is the value at T0. The loan amount is going to be determined by taking the 45,000 and scaling it back to T0, as well as the 50,000, scaling it back to T0 as well. So we take the compounding factor to the negative 3 on the 45,000 for those 3 years. And then for the other repayment, 50,000, we take the compounding factor to the negative 10 to calculate the value at T0. This is then our answer for the value of the loan.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from The Answer Series, your key to exam success.